For the sake of continuing the series of recordings that I've promised you, which actually corresponds to every lab that we take inside the campus, this is the video that corresponds to your 5th lab. We are going to extend on what we know so far on functions and what we have done in the 4th lab. If you don't really remember what happened there, just check the last video, which was actually the 4th lab video. Or if you want to check the documents or the slides, it's really up to you. They are all alternatives that you got. And next we're gonna see how can we not only pass single values to functions, but also how to pass multiple values, meaning passing collection of elements or passing lists into functions as arguments. The last section, which is the list of tuples, I think I'm going to shift this section to the 6th lab, just to not cram everything in one video, maintaining the length of the video in under of maybe 1 hour or 1 hour and a half. Okay, so without further ado, let's just recap what we have done in the 4th lab and what we know so far about tuples. We talked about tuples, and now we know that a tuple is basically an iterable, a collection of elements. A tuple, a list, a string, all of these structures are called iterables in Python. An iterable basically means that it's just a collection of items that you can essentially iterate through, meaning that if you passed this variable to a for loop, the for loop actually can iterate over each element of this string, and the same goes for the tuple, and the same goes for the list. All of them are iterables, and all of them are a collection of items that you can iterate through. Okay, so let's talk about first what we have done using the first feature, which is indexing or accessing. We said that we can access a list just by specifying the list name like this and writing 2 square brackets, and inside each square brackets provide the index of the element that you want to get. Say that you want to get the first element in this list, which is basically 100, so we're gonna pass the index of this 100, which is 0. Remember, this is 0, 1, 2, 3, 0, 1, 2, 3, 0, 1, 2, 3. And if you want to get the m inside this list, which actually falls in the index of 2, 0, 1, 2, so you're gonna say list of 2 like this inside a print function. Okay, the same thing goes for strings when you're accessing or indexing an element. Let's say that you want to access the first element, which is at the index of 0, so you're going to say the variable that contains the string. So the variable name is word, and the first letter, which is D, is located at the first index or position, which is 0, so word of 0 is going to get you D, and the same goes if you want to get the third element, which is at index or position 2, so you're going to say word of 2. Word of 2. This is going to get you A. And the same thing goes for tuples. If you want to access the first element of this tuple, which is 100, which falls in the position of 0 or index of 0, so you're going to say the tuple name, which is in this case tuple, and tuple of 0 basically gets you the first element, which is 100 in this case. Okay, we talked about slicing, and we know that we can slice as any iterable, whether it is a list that you are slicing or a string or a tuple. The thing is that you not only are gonna provide one index, now we're gonna provide like 2 indices. Maybe they're gonna be 3 indices, but essentially you're gonna provide 2 parameters. The first parameter in slicing is called the first or the start index, and the second parameter is called the end index, and the operator in the middle is called the colon operator. Okay, so when you say that you want to slice this list from the index of 0 till the index of 3, what you get is actually the elements starting the index of 0 till the index of 3, which will stop here. Remember, this is the index of 3. 0, 1, 2, 3. In slicing, we said that the end is not included, so basically Python does this. It starts from the start index, which is basically included, up until it reaches before the end index, which is 3 in this case. So it stops actually at 2, which is m. So it gets 0, 1, 2. The same thing goes when you are slicing a string. Let's say that you're slicing from 0 to 3, so it's gonna get 0, 1, 2. The third index, which is 3, is not actually included, so you get D. Okay, and if you want to slice the tuple, that's actually acceptable too. So you can say that you want to slice from 0 to 3 is the same thing. Slicing the tuple from 0 to 3 actually stops at 2. Okay, now if you want to reassign, let's say that you want to reassign whatever lies in the first position, or whatever lies in the first index, which is 100 in this case. You want to update it with a value like 900. So you say that whatever is inside the index of 0 within this list, just update it with this value on the right hand side. So Python takes the value from the right hand side and actually places it to the position of this list, which is on the left hand side of this equation or assignment statement. And when you print the list, now you're going to see that the first element is basically 900. Now if you try reassigning an element, an individual element in a string, this is not going to work, and this is basically the difference between strings, tuples, and lists. Basically, reassigning an element in a string or a tuple will not going to work, and it's going to give you a reassignment error because these structures are made to be immutable in Python. It does not allow you to reassign something. Once you say that the variable word contains the string deal, is going to be this. You cannot change individual items in the string anymore. And once you define that this tuple is going to be created out of these 4 elements, it's going to be this forever. You cannot change any of these individual items. Okay, and please notice that this is just a slight mistake. We don't have an index of 4 in this word. Like if you counted 0, 1, 2, 3. So what I meant here is saying word of 3, not 4. Okay, 4 is basically out of range. But anyways, if you tried assigning any index here starting from 0 to 3, this is going to give you an error string. So you cannot assign or reassign individual elements or update individual elements in a string. The same thing goes for a tuple. If you tried assigning the first position with whatever value on the right hand side, it's going to give you an error. Now, I'm going to just briefly talk about what we have done in the function part in the previous lab. If you actually understand this, just skip like 5 minutes ahead, and you're gonna see the start actually of lab 5 from here. Okay, so we said that functions actually, you need, in order to make a function, the first phase actually to define the function. You need to create the function, and creating or defining the function actually includes 3 parts. The first part is writing the definition keyword or the define keyword, and the second is writing the function name. This function name is anything that you want to call, and the third part is putting this parentheses. Essentially, you can actually have parentheses without any parameters, but if your function is designed to take what, like let's say 2 parameters, it works in 2 parameters, so you're gonna provide 2 parameters here. If it works, like if this function was supposed to add 3 numbers, for example, then you're gonna give 3 parameters there, x, y, and z, or x, y, and m, whatever. Okay, so basically the number of parameters that the function works on is dependent on the question itself. What does the function that you have or that you want to do, what does it actually do? On how many parameters does it work on? Okay, please refer back to the 4th lab and you're going to understand more about what I'm talking about. Alright, so let's say that add 2 actually, from the name it adds 2 numbers, so basically it takes 2 parameters, and whatever the value of these 2 parameters or placeholders will be, we will eventually just gonna add them together and store them in a variable, in a third variable called z. By the end of the day, you're gonna need to know the value of this z variable. So do not forget that you're gonna always need to return whatever stored in the z variable that you have calculated. Okay, remember, the thing that you calculate is the thing that you return. Okay, and a question is raised here: do our function always need to have a return? What if I said like print z? Would this be acceptable? I'm going to discuss this area in this video, but the quickest answer is no. You don't have always to have the function having a return keyword. The function can return, the function can print, the function can do both things. It can return and print. This actually is dependent to the question itself. Does the question is telling? Does the question tells you to that the function should return something, or does the question is saying that the function should print, not return? It's up to the question. Maybe the question you're assigned isn't actually saying anything, so it's totally up to you whether you want to return something or print it. But remember, returning the value that you have calculated inside the function is always useful, because this actually gives you the ability to use it afterwards in your code, or even pass it to other functions. And this is the first step, which is the function definition. The second phase, which is the function call or the function usage, or executing the function or running the function. All of these have the same meaning. Is essentially calling the function by the name. Like you called the function here add2 when you defined it, right? This is the definition. Okay, not that there's an indentation here saying that these couple of lines or these two lines are happening within this function when it's called. So you call the function by the name that you give it. We said that it's add2, so just call it with add2. Now you said that in the definition add2 takes two parameters. Now in place of these two parameters, you need to actually pass actual values, which we call arguments. So let's say that we're gonna pass two arguments, and remember we are only passing two because the function is defined, or in other words, you define the function as it takes two parameters only, or two arguments only. So let's give it like 3 and 6, basically within the same order that you gave these these arguments. They're going to be placed in these placeholders or in these parameters. So if you give the beginning 3, then x is going to be 3, and if you give the second one to be 6, then y is going to be 6. Now Python is going to call this function, and whenever it calls this function, it's going to pass to it 3 and 6. Then it's going to execute the block of the function, what's written inside the function, with the knowledge of that x is 3 and y is 6. So 3 plus 6 was going to be stored inside the z is going to be 9. Okay, so the function returns 9, right? So basically, instead of this call right here, Python is going to replace this call by the value returned, which is in this case is going to be 9, and 9 is going to be stored in the variable on the right hand side, on the left hand side, which is a result. So if you print the result, you're going to see 9 right here. Okay, now we said that we can actually make the function return multiple values. Again, all of these were actually detailed, were explained in details in the previous video, in the fourth video. So you can just watch the end of the last 20 minutes of the fourth lab, and you're gonna see everything being done practically from scratch. This is just to recap what we have done so far. Okay, so we can make a function return multiple values. In this case, we are making a function that adds and subtracts two elements. So let's say that we are actually adding and subtracting two elements. So basically, we need two elements to add or subtract in the first place, right? So that's why I'm having x and y here. Basically, this can be anything. They are just placeholders. They're gonna change upon the value that you pass when you call the function here, or in this example there. Okay, so basically this can be a comma b, x comma y, m comma n, whatever. So I'm just making my parameters x comma y. All right, now this function is supposed to add and subtract, so I'm just saving the addition result in z1, and I'm saving the subtraction result in z2. Now basically you have two variables, you have two calculated values, which one resides in z1 and the other resides in z2. So basically you need to return both of them. And we talked about multiple returns in the fourth lab as well. We told you, or I told you, that to return multiple values, just separate the variables by a comma in between. Okay, and this thing here basically gonna return a tuple. Okay, when you separate two variables by a comma, you should know that the returned value, the returned overall value from this thing here is just a tuple, and the first element of the tuple corresponds to the first returned value in this variable, and the second element of this returned tuple corresponds to the second returned value from this variable. Okay, now in order to access the returned value, the first method that we talked about is called tuple unpacking or tuple unpacking. Unpacking is basically works like this. Now we said that this call, guys, when you have an assignment statement like this or an assignment line like this, always remember that you need to evaluate the right hand side before knowing of, or before considering whatever on the left hand side. So let's start with whatever on the right hand side. On the right hand side we see a call, a function call, or a function run, or a function execution, which actually addressing the function that is called add sub2 that we actually created here. Okay, so we are calling this function, and while we are calling the function that is add sub2, we are passing two arguments. So the 3 and x is going to be replaced or substituted instead of x and y. The 3 and 6, I'm sorry, is going to be substituted in place of x and y, and the function is going to execute with the knowledge of that x is 3 and y is 6, and this is going to result of 9 in z1, and it's going to result of -3 in z2. So basically the returned value is going to be a tuple of 9 and -3. Okay, so instead of this call, the returned value that is going to be in place of this call here is going to be the tuple that is 9 and -3. And note that 9 is the first returned value, which you said in the beginning that you're going to return z1, and the second returned value is the second returned variable. Okay, see, the order here matters, right? So this tuple, if you want to unpack this tuple, you can have like two variables on the left hand side, meaning that the left variable is going to store the first element of the tuple, and the second element of the tuple is going to be stored in the second variable. Okay, it's like saying that 9 is going to be stored in result 1 and -3 is going to be stored in result 2. So if you printed result 1 and result 2 right now, you're going to see 9 and -3. Okay, now this is the first method, which is tuple unpacking. If you understand this, you don't have to do it the other way around, and basically one of the two methods work. The second method is basically called indexing, and you know that any tuple, like any list, like any string, are actually positioned or indexed at certain indices, saying that this element is at 0 in this list and this element is at 1. Same thing goes for a string, this element is at 0 and this element is at 1. Same goes for this tuple, this element is at 0, index of 0, and this element is at index of 1, and so on. So with this knowledge, if you have a tuple like 9 and -3, basically you know that the first value of this tuple corresponds to the first returned variable, which actually is z1, which actually contains the addition, right? So basically the first index of this tuple, the first element, which is at index of 0, this is the addition, and the second element of this tuple, which is at index of 1, this is the subtraction, which corresponds to z2 variable that is returned, which actually holds the subtraction operation. Okay, so from this tuple, index of 0 is addition and index of 1 is subtraction. Now calling the same function with 3 and 6 is going to be substituted. This call will be substituted with this tuple right here. Okay, so this tuple 9, -3 is going to be stored in the variable on the left hand side, which is result. So now this variable result contains the returned value of this call, which is this tuple 9 and -3. Okay, this is stored inside result. So if you say result of 0, this is going to get you the first element, which is the addition, which is 9. Okay, And if you say result of 1, which is basically the next element of this return tuple, which is -3 in this case, and you printed both of them, you're gonna get 9 and -3. Okay. Now, the most important list methods that we're gonna work around in this fifth lab is basically the append method. But I'm going to I included the sort method just in case, because they are essentially the most important methods that you're gonna read in your assignment. Now let's say that we have here, I know that I've talked about this before, but this is just a recap. You can skip these couple of 3 minutes, the second 3 minutes, and get to the first problem in this lab. Okay, so we have here an empty list that is called names. Right? If you printed names now, you're gonna get just an empty square brackets. There are no elements yet. When you say the list name, which is in this case we call it names. When you say the list names dot append, basically this method append is going to take whatever value that you pass inside these parentheses and insert it into the list on the left hand side. Okay, the same thing will go for the next appending case. You're appending now a value, a string called Ziad, for example. So you're gonna take the value that you're passing to the append method or function, and you're gonna insert it to the attached list name. Okay, and again, I've said all of this stuff in the fourth lab. Please check the fourth lab for more detail. Okay, so the last thing here, we have sort, and sort method actually works in this way. Notice that the last append that we have made, which is Barry, we have now 3 strings. The first one starts with an alphabet of A, the second an alphabet of Z, and the third is alphabet of B. So basically, when you say this list name, which is names dot sort, it basically sorts the element of the list that you're attaching the method to, which is in this case names. So it sorts the elements of this list from, basically, if you have strings in this list, so basically it's gonna be sorted based on the first alphabet of each string. If you have numbers in this list, so it's gonna sort it ascendingly from the smallest to the largest. Okay, so let's dive into the problems. Now the first problem, which is sign detector, I believe this program we have done it by the end of the fourth lab, so let's just check the other one. Here we want to make an even odd detector function, and this function takes one number as an argument, so basically it takes one argument. It determines if a number is even or odd. Okay, and if the number is even, it should return, okay, it should return the word even, and if it's odd, it should return the word odd. Okay, so this is what I meant by telling you that functions do not always need to have a return keyword unless there is a return mentioned in the question. If the question itself or the program itself needs the function to have some kind of a return, then this is the case when you want to return that value. Okay, if there was not a specification on what does the function should do after it like determines something or calculates something, if there was no specification afterwards, then it's really up to you if you want to return the word even or print the word even or even odd. Okay, so let's start by I have a folder here. I created a folder. Actually, it's placed on my desktop right there, Lab 5 screencast. I'm just gonna say right click on that folder and make a new script. Let's call it trial. Let's call it, I don't know, programs.py. Okay, now we are making the second program, which is actually an even odd function detector. So basically we are gonna start with the first phase 1, which is actually defining the function. Okay, so let's say define even odd. See, you abide by the program itself. The question itself is telling you that name it even odd detector, so I'm going to do the same thing, even odd detector, like this, and within the parentheses it should determine if a number, and it's told you, or it's have been specified here that it takes one argument. So in order to pass it one argument in the call, which is the second phase, we're gonna prepare one placeholder for that argument in the definition, which is in this phase. So this placeholder is gonna be, I don't know, x, a, n, whatever, just a placeholder, a parameter. Okay, so don't forget your column. Now notice if you put this column here, you're gonna have this indentation done automatically for you. Now let's say that we have x, and x is basically a number, any number. So in order to check if this number is even or odd, we always use this percentage operator, which is the remainder operator. So let's say if x is divided by 2 and the remainder was 0, this means that x is an even number. So basically we return the string even. Okay, else if it is not returning 0, or if dividing the x or the number by 2 and the remainder, which is the percentage here, is not 0, meaning that's gonna be odd or something, then basically return the string odd. Okay, and this is the definition. We have finished the definition. So let's go to the second phase. Notice how I deleted this indentation here, meaning that I have broke out of the function. Now I'm out of the function. Okay, so this is the second phase, phase 2, which is basically calling the function. So calling the function, as I told you, it is just about writing the function name, and basically VS Code will suggest this function. It knows that there is something called even odd detector that is defined somewhere in this script. So just hit enter and place the parentheses after the function name, and just pass the number of arguments that the function actually is expecting. We define the function as it expects one number as an argument, because we have done here, like we have made like one placeholder or one parameter. So we pass here like 2, whatever, 4, 3, anything. Okay, so if you run this, you're not gonna get anything. Notice that this is the call. Okay, this is the call, and we have finished the call. But when you run this, nothing gets printed, because yeah, as you guys said, we never printed anything. So let's print whatever this function will return. Notice that based on this number that we are passing, the function is gonna return either the word odd or the word even instead of this highlighted code. So if you pass like 3, notice that there's gonna be odd return instead of this highlighted code. When you print, you're gonna see odd right there. Okay, if you pass now something that is even and you run, you're gonna get the even return. Okay, now if you want to save whatever is returned by this function into a variable, then printing that variable, it's the same thing. Like I have saved whatever this function is gonna return in a variable called result, and now I'm printing result. And notice that I can even change now the passed argument to make it something like 1 or something. It's gonna return odd. Okay, and instead of passing static values, let's just pass an input. Let's call it n. Let's say input, and tell the user enter a number. Notice that the input function, just a reminder for you, the input function is actually returns a string. So basically you need to cast anything that you want to store as an integer into an integer using the int casting function. Now whatever you enter as an input is going to be saved as an integer, because we have taken it and cast it an integer and saved it into n, and this n is going to be passed into the even odd detector function. Okay, so now run this, and you're gonna see the prompt that you have written inside this input function is appearing here in your terminal. Now just pass any number, which is, maybe it can be even, it can be odd, whatever. If you pass an even like this, or maybe 8, it's gonna tell you that the number is even. Okay, so this is the second program. Now let's see the third one. The third one is actually asking you to make a function and name it as square. And from the name itself, you know that the return is going to be the square of an entered integer, and it's telling you that the function is taking only one argument. Okay, and the function, after it calculates the square of an entered integer, it returns. Okay, in this program, it's actually really obvious that the function will return, not print. And just let me rephrase what I said before. Now notice that this function actually returns, right? We never did something like this. We never said like print even. Yeah, we said return the string even. And because we have a return inside this function, we intended to do like whatever this function is gonna return. So please save it in a variable, whatever this variable name will be. Okay, and this is a very important rule when you have a return. If the function returns something, always prepare a variable on the right hand side of the call if you want to save this return. Okay, so what is the case if you're gonna print instead of returning? Let's say that I'm going to print either the string even or print either the string odd. Okay, now notice that when there are no returns in your function, this variable to the right hand side of the call is really it doesn't make any sense. It's meaningless because this function, this highlighted call, it does not return anything. So what you are actually storing in result is something called none, which is basically nothing. And I'm going to show you that result now contains none because there's nothing returned from this call, and this is what's going to be stored in result, and this is what's going to be printed by the end of the day. So if you run this and you enter something like 7, which is odd, and you press enter, you're gonna see odd, and this odd is basically coming from inside the function. Let me rephrase, or let me just recap what we know about functions so far. Now, I told you that when Python confronts a call like this, okay, Python was going to face a call in line 14 in this line. When it sees a call to any function, it's going to look for the function named even odd detector, which is going to be found starting from line 5. Okay, and it's going to take whatever value that you have passed as an argument to this function. And notice here that we have passed 7 into n, then we passed n to the function. So it's gonna take n that holds the value of 7 inside this function. Okay, and it's gonna execute this function, but before it executes the function, it's gonna replace the parameter here with the value that you have passed it with, and you passed here 7, so it's gonna take the placeholder that you have put inside the function, which is x in this case, and place it with 7, right? So it's gonna execute the function with the knowledge that x is now 7, which is the passed argument in this call. Okay, and basically the first if is not gonna be true. That's why we will see the odd being printed. That's what I meant when I said this odd that appears in the terminal is basically corresponds to this print inside the function. And even if we entered 8, we're gonna see even, and even is going to be printed from within or from inside the function. Okay, so what's going on with the none thing? As I've told you, there is no return in this function. Okay, so there is no actually need for you to say result equal or res equal before the function call, because the function call is not returning anything in the first place. So that's why it's gonna return none, meaning that the function returns nothing. That's why you see none is printed, and none is basically what's stored inside result and what is being printed at the end of your code. Okay, so if you have like only prints inside your function, you are not using any returns, you can say something like this. You can actually remove this left hand side variable that you are storing, because there's nothing to return and there's nothing to store. Okay, so just remove result and remove the print at the end. Now if you have only prints within the function, you can actually it is really enough for you to call the function and pass an argument to it. That's the whole thing when you are calling a function that contains only print statements. Okay, and whenever you enter something, you're gonna see like one of these two print statements. But if you are having like two returns or whatever, multiple number of returns are returned in each if statements, in this case you're gonna need a variable to store whatever is returned from this function in a variable. So you're gonna need a variable on the left hand side. Okay, now I hope this is clear. Now let's go to the third program. The third program is called create a program called square. And remember, a very good practice is to stack your functions on each other. Like say that we have a function definition here. If this is too much code for you, you can actually use this minimizer here, so you want to see everything that is written. Now Yeah, let's minimize it, and let's make another function and call it square. Okay, and square, it actually squares one number, so we're gonna give it a single value. Let's call it x or something. Now you are passing x. What are you going to do with x? You're gonna square it, right? You're going to square x. So how do you square x? It is just this easy. It's either saying to the power of 2, or it's either saying x multiplied by itself, x by x, whatever suits you. I'm going to pick the first method, and we can actually store this in a variable called z, then return what? Yeah, return z. Okay, and basically you can do this in one shot, meaning that you can actually return whatever will be calculated from this part here. So you're gonna say return the calculation of this operation right here. You don't need a third wheel or a third variable called z. The function definition phase is finished. Now let us call the function, and let us say the function name and give it an input. Let's say that the input that we're gonna take from this input function that has already been passed once into the even odd detector is going to be passed again into the square function. Okay, and now let us save the return of this square function in a variable, just as we did with the even odd detector, because remember, the square has a return. So if you have a return, remember, you need a variable to the left hand side of the call. Okay, so let's call this, I don't know, maybe result of square, result is q. Okay, now let's just discriminate each print. Let's say that the first result is basically type of number, and let's say the second print is basically printing the square of number, just to not get lost within all the printed statements in the terminal. Now let's run this and enter an input of, for example, 3. This is going to be, remember, this is going to be odd, and I believe it's going to give you 9. Okay, so the type is odd. This is basically the return of the even odd detector function, and the 9 is the return of the square function. Okay, now let's see the fourth program. I'm going to get back to this just in a moment, but alright, so this program is actually saying that you want to make a function and call it exponent. The function takes 2 arguments, the number and the power, and it should calculates and returns. Remember, there is a return in the question itself, so the function should return the result. Okay, it returns the exponent of the given number and its power. Let's see this run example. Okay, so it's telling you that if you call the function exponent and give it an argument of 2, which is the number, and a power of 3, so this is saying that 2 to the power of 3, the result that's going to be returned from this exponent function is going to be 8. Okay, and another example is calling the function exponent by giving the number as 3 and the power as 2, which will be 3 to the power of 2, and the returned exponent or the returned value from this function is going to be 9, and this is going to be printed. Okay, so it's really similar to the square function. I'm not going to minimize the square function because we're going to actually need this part. So let's define it and call it exponent. Okay, now remember, exponent takes 2 arguments, so let's prepare 2 parameters or 2 placeholders. Let's call the first one n, and let's call the second one power, or power, only power. Okay, now I've copied this line because we're gonna edit only one thing. In the square, you always take the number given to the function and give it a power of 2. In exponent, you take the number given to the function, which is in this case not x, it's n, and give it the power of not 2, yeah, you guessed it, whatever is going to be given in place of power. Okay, so this is the exponent function. Right, so let's call the third function by its name and give it the first number, which is going to be the same input that we used in the previous 2 calls, which is for the square and for the even odd detector, and pass here n. Okay, now the power, this actually is gonna yeah, I mean, this is gonna need another input, but let's just make it a static a static power or static value. Let's say that the power is going to be something like 3. Okay, and let's save whatever is returned by the exponent in a variable and call it result of exponent. Okay, now let's make another print function and call it exponent of number is going to be a result of exponent. Okay, alright, let's run this program now, and if we give 3, okay, you're gonna see that 3 is going to be odd, which is corresponding to the first function call, and for the square function call 3 is going to be 9, and for the third one 3 to the power of 3, this is going to give you 27. Okay, so the last one was the returned value of the exponent function. Let's try giving another type or another number for the power. Let's give it something like 9, for example, and let's give the input as something really small because we don't want to see a very large result from the exponent function. So 2 is gonna be even from this function, and 2 to the power of 2 is going to give you 4, and 2 to the power of 9 is, I guess it's gonna be 512. Yeah, it's gonna be 512. Okay, so, and instead of the static value that I'm passing, let's take a value from an input, just as the input we have taken from this line 21, where we take the actual number. Let's say that we are going to make another variable, call it power, and pass it an input from the user. So we're gonna ask the user enter a desired power value, and do not forget to cast whatever is entered into an integer, like that. And instead of giving 9, let's give whatever input the user will insert and be stored inside the power variable. Now let's run this. The first thing is going to ask is the first input, which is line 21, that's going to be saved into n. So that's the actual number, which is 2. Now it's going to ask you for the power itself, which is 24, the line 24. So let's give the power something like 10. I guess it's going to be 1024. Yeah, 1024. This is the exponent. Okay, I hope this is clear to you. Okay, now the real question is, what if, let's just comment this, and let us say that I have called the exponent function and I forgot to provide a second argument which actually corresponds to the power. I only gave this function the number, okay, which is the first parameter. Now obviously it's gonna give you the error of there are missing arguments. Even if you run this and you entered the first input, when Python hits this line 25, is gonna give you an error. So let's say that we are giving something like 2 for the number, and it's going to tell you that there is a missing one required position argument, which stands for this placeholder or POW. Okay, now I know that the solution, you might say, would be, why would I forget something like this? Like, I have literally just created the function, and I know that the function takes 2 things, so why not only just give it the second argument, which stands for the power, or the POW in this case. I mean, I know that this is true, but sometimes when you are writing a very big code base, you don't always remember what does the function that you defined when you started this project, like 3 or 6 months before, what does this function actually takes. So what you actually do is you either write a documentation for this function, and I will not include this part in this video. You can actually search it online in how to write something called function docstrings that actually helps you to identify what the function is waiting from you. But this is not the case here. We're not gonna write something called docstrings. Okay, so the obvious solution would be to go to the top of your script and write and search for or scan for every function that you have until you see the exponent function. Okay, and you will see that you have defined this exponent function as it takes 2 things or 2 parameters, or even you can actually I mean, you can't tell that this exponent function is missing one required argument from this error message here. You don't have to go all the way to the function itself. But I'm just saying that these are the alternative ways that you can do, okay? The safest way to go is using something called default parameters. What is a default parameter? Is basically saying something like this. Okay, what I did here is basically saying that this function is anticipating a variable, which is the number, and it is expecting another variable or another value that is the power. And in case the user didn't actually provide this second value here, the function will use the default value that we have set in the function header, which is in this case 2. Okay, so basically, if you are, I'm not going to use this input function, this input line, because I think it's gonna confuse you. So let's say that here, when I'm calling the exponent function, I am actually specifying that the power is going to be 9, for example. So when you actually give an argument that corresponds to the second placeholder, this too will be overwritten. It's going to be overwritten by whatever value that you passed. So let's say that you have passed here 9. When this function is called, this function definition will be executed. So it's gonna substitute power with 9, not with 2. Now let's test this and give the number by 2. You should see that 2 to the power of 9, because this is what you provided in the call, and this is really what actually matters. This is just, consider this just a backup plan. Okay, so this 2 will be overwritten by 9. So you're gonna see when you hit enter 5 to the power or 512, which is 2 to the power of 9. Now let's say that I haven't provided the next argument, which is 9, like this. I have removed the second argument from here. The beautiful thing in using default parameters in the function header is that you're not gonna get an error message telling you that you are missing one argument, and your application will not crash at all. It is just going to use the default value that you have set for this placeholder. So if you're given only the number and there is no power next to it, there's nothing like comma 9 or comma 8 or whatever, it's going to use the default value that you have set in this function header. Okay, so let's run this and give it something like 2 again. Now remember that the default, you have not provided a power, but you have a default power of 2. Right, so 2 to the power of 2, this is going to give you 4, which is the same value that the square function will return here. Okay. Alright, let's see now program 5. Program 5 is telling you that we need to make a function and call it OddsGrabber. And from the name, you know that you're gonna have some kind of a range of numbers, and you're going to grab the odd numbers from this range. Now let's continue the question. It's telling you that this function, it takes 2 arguments. As you can see from this snippet of code, this example that I've provided you with, it's telling you that you're gonna take 2 arguments. The 2 arguments, the first argument is called a start value, the second is called an end value. Okay, which are the start and end of the sequence of the numbers. Using a for loop, the function should implicitly generate a sequence of numbers. And how do we generate a sequence of numbers using a for loop? We always used to say something like for x in range. Remember, the range function is the function that we need in order to generate a sequence of numbers. Okay, then after we create a range of numbers based on the start limit and end limit of this range that we will provide the function itself, we will iterate through these numbers and append whatever odd number that we meet within this generated range. Okay, and the empty list that we will append the odd numbers in is called odds. Right, this is created inside the function. Alright, and it should return, by the end of the day, this function should return the odds that we have appended. Okay, so let's check this example here. If we completed this snippet of code before we see this output example, you'll see that this function itself, it takes two arguments, as we have discussed before. It's telling you that it takes a start value or a start limit, and an end value and an end limit. These are the parameters or arguments that you are going to pass to the range function within the for loop. Okay, so whenever you have this, you're gonna have a set of sequenced numbers generated by the range function inside the for loop. And the for loop, what it will eventually do is that it will iterate over this range of numbers that it has generated when you say for x in range, like starting 0 to 10 or whatever. Okay, once you have the for loop settled, once you have the for loop head or header ready for you, you will now check if the element you're iterating through, if it was odd or not. If it was odd, then simply just append or store this element inside the empty list, which we called odds, inside the function. Okay, once we finish the function definition, after we finish the function definition, we will get out and we will ask the user to enter the starting value. Instead of giving the start value and end value as static values, we will ask the user to enter the starting value and ending value. Okay, and we will store the starting value in a variable called start, and you will store the stopping value or the ending value in a variable called end. You can call this whatever. You can call this x, y, whatever. I just want it to be the variables to be more meaningful. That's it. Okay, then you will print whatever the odd or the OddsGrabber will return, which in this case is going to be the odds list here. Okay, so this output run is telling you that the prompt that you're seeing here is basically the prompt within this input function. And let's say that I have entered something like 2, right? And I've entered a stopping value. See, this prompt is from this line, okay? And I entered some stopping value like 11. Now the odds between 2 and 11 is 3, 5, 7, 9, 11. Notice that if the end was odd, the odd itself should be, or the end itself should be included. Right? Now, if we give something like 2 to 10, 3, 5, 7, 9, it will stop before, or it will stop at the last odd number within this range, or within this two limits that, or these two extremes that we have provided. Okay, so just take care that the stopping value needs to be included within the appended odd numbers. Okay, let's see how this is going to be implementing using Python. Now I'm going to copy this snippet of code here and go to VS Code. Okay, let's make a new script and code, I don't know, trial2.py for example. Okay, and copy this snippet of code here. Right, now we should complete this part, so I'm just going to cut this comment out. And remember, once you remove this indentation level, this cursor right here, when you see this at the same level as the defined function, you should know that you are out of the function. The function has been closed. Right, so let's say that this is the start of program here. Right, so the start of program is right there. Okay, now remember, we are taking an input from the user, a starting value, and we're taking another input from the user, a stopping value. Right, I'm just going to cut this call right there. All right, and let's work on the function a little bit. Okay, so we're saying in the function we're taking a start value and an end value, and we are preparing an empty list called odds. So remember, we need a for loop. Okay, so as I told you, you need a function called the range function. The point of the range function is that you pass a start value. Okay, say that you're passing something like 0 and 10. I'm just going to do this out of the for loop just as a reminder for you. Okay, so when we used to say for x in range or whatever, and we give this range function a start and an end, remember we can give a step too, like the step is the third argument here, and just print x. So what's going to be printed is the sequence of numbers between 0 and x. This is 0 and 10, this is x. Okay, x is going to be every number from 0 to 10. Right, so when you print this, you're going to have from 0 to 9. Remember that the end is not included, so if you want to have 10 with you in the sequence, just increment the end by 1 like this. So you're gonna have the end to be 11, and this is basically what I meant when I said in the question that you will use the range function in a for loop. Okay, so we need this part, so I'm just going to get this here inside the function. Let's just indent this so it's going to be inside the function. Now remember, we are not working on a range of numbers that is starting from 0 to 11. We're actually working on a range of numbers that start from whatever the start value that the user will provide to the function, and up until to the whatever end value that the user will provide to the function. All right, and remember, we don't really need to print the numbers itself. What we want actually to do is to iterate over each element, and this is what the header of the loop is doing. Like when you see this line here for x and whatever, x is basically the iterator of the for loop, which is going to iterate each every element inside whatever the for loop is accessing. Okay, so in this case the for loop is accessing a range of number that starts from whatever 0 to whatever 11 or whatever. So basically the x is going to iterate over each element inside this collection of numbers, or in a list, as we have seen before. Okay, so now we say for each element that I'm currently iterating, if this element is divisible by 2, okay, if I divided this element by 2 and it gave me a remainder of 1, this means that the x in this case is odd. Yeah, so if it is odd, so now we can say that we're gonna append this x into the odds empty list that I've created in the start. Okay, this is the question, that's the solution right there. Okay, so that's it. Now by the end of the day we should return what? We should return the odds. Okay, so let's just comment back these input lines, and now let's call the function and save the result or the returned value in a variable called result. Let's call it result odds, for example, and give it something like, let's call the function and give it the start that we have taken as an input here, and give it the end that we have taken as an input here. Okay, so this is the start and this is the end. Yeah, now print results. Let's run this. There is a problem. Okay, let's re-indent everything because there's a problem with the indentation here. Okay, I have just re-indented everything again, so if you have this indentation error, it's fine. Just like set everything to default, like remove every indentation like this, and then you should like indent every line manually. Okay, and when you run, you should see this error has gone. Alright, so I have ran the program and it's asking me for the first input, which is the starting value. So let's say that we are executing this example for instance. We're giving this starting value to 2 and the ending value or starting value as 11. So let's say that I'm going to enter 2 and 11. Notice something, that the starting value isn't with me. So basically there's some modification that I need to do. Now notice that if you have run this program and you're given something like, for example, 2 to 10, like the end is something that is even, for example, you don't have to worry about this because basically the 9 is included within the range of the for loop. But when it's 11, when it's actually the ending limit of the range, that is the problem. Okay, so the only thing that we need to do is to check if the end was an odd number or not. Maybe the end is odd number. If it is an odd number, then we need to increment it by 1 in order to get it included within my generated odds numbers, right? And if the odd number was not, or if the end value was not an odd number, so we're just going to leave it. There is no else statement here. So I'm just going to say if the end value was actually, if I divided by 2 and it gave me 1, so this means that is it is actually an odd number. The end value is an odd number. So basically say that the new end value is going to be the same one as before, but plus 1. Okay, this is saying that if I enter something like 11, so 11 plus 1 is going to be 12. And this will guarantee me that 12 is not going to be included, but 11 that I have provided to the function will be included. And notice that there is no else statement. I don't care if the number or the end value was even, because if it was even, then basically then it will not be included. So there is no need for an else statement here. So this actually does the trick. Let's run this and give the starting value something like 2 and 11 at the end. Okay, now you have 11 with you. Okay, that is program 5. Now let us discuss the most important part in this lab, which I remember it's basically passing lists into a function. Or maybe I'm going to discuss something before this. Remember when I told you that there is a slide called printing versus returning inside the function? Like, what is the difference? What is the difference if I like included a return inside the function, or I replaced the return with a print instead inside the function? What is the difference here? Okay, so let's just discuss this as fast as possible. And I believe I made a script for this. Yeah, print versus return. Okay, let's just, we don't want to get any errors, so let's say pass here. Okay, now remember the square function that we have discussed earlier when I told you that the square function actually takes a single value, right? A single number, and whatever, you should like only calculate the square for this number. So you say something like n to the power of 2 or n multiplied by 2. It's the same, essentially it's the same meaning, right? But the thing is, remember when we said something like this, let's make it to the power of 2. I don't know, I like this better. Okay, so let's say that we are returning this whatever that's going to be calculated from this operation, right? We have made this function return this value based on the question. If you remember correctly, the question itself, it told you that the square function, it should return, yeah, the function called the square here, it should calculates and returns. That's why we have actually made the function return, not print. So let's take the cases, let's take the 3 different cases. The first case is, what if the function returns at the end of the function? Yeah. What if the function by the end of it print? What if the function by the end of it return and print? Okay, so let's take the first version here, version 1, that the function square returns. And this, we know this, we actually have done this before at the beginning of this video. So remember our program. I'm sorry. Our program starts here. Now let's call the function, and I'm just going to give it a static value, like, I don't know, maybe 3 or 2 or whatever. And remember, this function now returns. If you call this, this is the function call. Okay, so this is calling the first version of square func. Okay, so if you call this function, nothing will happen because we never printed anything. This function does not, by itself, it does not print. It returns. So basically, if it returns, as I told you before, you need to prepare a value or a variable to store this return end. Yeah, so let's store this in something called result, or let's make it result 1. I don't know, let's make it result 1 since we have 3 different versions. Okay, so now you can print result 1, and you should see the output of 9. And since we know that any return should be printed, I'm just going to print whatever the call will return just immediately, like this. Okay, and it should essentially give you the same output. Now let's think about this, the next one. The next one is telling you that the function by the end of it, it should print. Yeah, so, and instead of saying return, we will say print the value that's going to be returned from this operation. It's the same squaring operation here. Okay, so now let's call this function square version 2. Notice that now we can actually call the function without further ado, without anything extra. That's it. Just call the function and pass whatever value that you want to pass. Okay, there's no need to wrap this function with a print like this. We are just wrapping this version 1 square function with a print because the function itself, the square version 1 function itself, it returns something. So instead of this highlighted call, since there's a return here, you're gonna find the value or the output of this operation. Yeah, so instead of this highlighted call, function will or Python will implicitly replaces this highlighted call with the value of the returned calculation. Like in this case 9, because you are providing 3. That's why we see 9 printed in the terminal here, right? But there is no point in printing whatever is going to be returned from the call of the second version of the square function, since the second version itself does not return anything. Okay, so there's no point in doing something like this, and there is no point in doing something like this. Okay, there is no return. So what are you printing? There's no return from this function, so there's no point in printing. The same goes for storing whatever the function will return. The function call will return. The function itself does not return anything, so the call will not return anything. So you are storing basically none. So if your function has only print statements, you can immediately just call the function as it is, like this. So if you run this, you're gonna see that this 9 is from the square version 1, okay, and you're gonna see that the 16 is from the square version 2. Okay, so let's just test the theory of printing whatever this function will return. I know that I've told you that this function returned nothing, but let's just see if we try to print the nothing that this function will return. How would this look like in the terminal? Now, if you run this, you're gonna see that this 9 is basically the print of the first version of the square function, and the 16 is the print of the second version of the square function. Notice that this 16 is basically the implicit or the internal print. Okay, this is the internal or the inner print from this square function, square version 2 function. Yeah, but the none here is basically the print out of the function. You're trying to print something that does not exist, because this function actually does not return anything. There is no return within square version 2, right? So that's why Python is trying to print anything that this function is returning, and this function is not returning anything. That's why you're seeing this none here. Okay, and if we have done the same thing of like doing this on 2 steps, like storing whatever value the function will return in a variable called, for example, result, and printing result, is going to yield the same output. It's going to give you none 2. Okay, now notice that there is actually a warning that Python gives you. It's telling you that you are assigning a result of a function call where the function has no return. So it doesn't make sense to Python. There is no return in this function. So why are you even assigning a value that is basically none into a variable? This is not helpful at all. Yeah. So this is the second case. The third case, what if I wanted to have a print and a return in my function? And this will be most of the cases. You can actually have a print and a return in your function. That's fine. So say, for example, that notice that in this case I'm going to use a variable. Let's say that I'm going to store the result of this operation, which is n to the power of 2 and z. Now, if you want to print the value of z, you can say something like this. The result is z. That's one thing. Let's make it an if string. Okay, just to remind you. So the result is, okay, and let's say that we are going to return the z. So we are printing the value of the z and we are returning z, and it's fine. Okay, now let's call the third I should have edited this. On the third version of square function, and let's say square function version 3 and give it something like 5, for example. Now this call actually yields this print function, because when you execute this function, you're gonna see this function has been executed, right? So what's inside this function is this print statement. Now let's say that we will do the same trick that we have done to the first function that included a return. Remember that this function now includes a return, right? So actually it is really fine with, if I did something like this, result equal the call of the third function, and it is fine if I printed whatever will be stored inside res variable. Now notice here that when this function calls is executed, you're gonna see this statement. When this function call is executed, this whole 3 lines, the function will execute. So these 3 lines will execute. So the first thing that you're gonna see after the z will be calculated, you're gonna see this print statement here. Okay. Now when this line, when the function is executing and the 15th line has finished, the 16th line, which is returning whatever is going to be stored inside z, that's why I needed to store the result of this operation in a variable. Whatever value that's going to be stored inside z will be returned. So instead of this highlighted call, if you're giving something like 5, the returned value of this call is going to be 25, and this is going to be stored inside result, and we will print by the end of the day 25 by the end. So you're going to say the result is, you're going to see the result is 25, then afterwards you're going to see 25 printed as it is. Okay, so just run this now and you're going to see what I've told you. This is the first version, this is the second version, and this is the third version's print statement, the inner print statement, and the last one is the returned value that we have got from the function, okay, and stored inside the variable result, and print and we have printed whatever inside the variable result, which is in this case 25. Okay, I hope this is clear to you. Right now, okay, so let's discuss the most important topic, as I was talking about earlier, which is passing lists into function. Now let's just make a new script and call it trial3.py. Remember, what we have been doing so far is passing single values into a function call. Yeah, so basically what we have done within the square function, when we define something called square, for example, and we say the square function takes a number which we actually say that is going to be named as x, and this is implying that x is going to be a single value. Right? In coding, when you are referring to a single value or a single element, you say that this single element is going to be n, x, b, a. But whenever this element is something bigger, meaning that this element is actually a bunch of elements, a collection of elements, a list, for example, you do not actually name the given list as x. Okay, meaning that if you have a variable called 4 or a value of 4, you store this in x, for example. Okay, but if you have a list, you didn't say that the list is equal to y like this. Now you can actually do this, but this is not a good practice. Remember that this code, at some point of your life, this code will be the integration of so many developers. So many other team members of your team, if you considered yourself in a company or something, or in a project, so many other members are going to look at your code. And if you have a list called y, this is not a good practice. How would they know that there is a list inside y? In programming, when you look at a variable like this, like x, like y, we just immediately think of this variable that it holds a single value like this. But if we have a list, we name it something more meaningful. We name it something like list 1 or array 1 or array whatever, but something that actually implies that this will contain a collection of numbers. Yeah, so remember the naming conventions. It's really important in programming. Now, when we say that the function takes x, we, without a doubt, know that this x variable will contain a single value. Okay, so we continued on this concept, saying that we will return x to the power of 2, for example. So, see, this function actually accepts what? Accepts a single value, which is x. Okay, and when we were calling the function, we used to give it something like 2, right? And we said something like whatever, result equals square. Okay, but this is not the case now. The case here is actually passing multiple values, or let's say collection of values. And by collection of values, I mean any iterable. And an iterable can be a list. We can pass a list. We can pass a tuple. We can pass a set. I know that I haven't introduced you to sets yet, but we know so far that any iterable can be a list, tuple, or yeah, we talked about strings. A string is actually an iterable too. So this is what we mean by passing a collection of values. Okay, so let's just talk about lists for now, because this is the most important one, into a function call. So in order to pass a list into a function call, the first noticeable thing that you need to understand is the function definition itself should accept lists in the first place. Okay, in order to be able to pass a list into a function call, the function definition itself should accept lists in the first place, meaning that when you define this function, when you define the square function, which I actually abbreviated to SQ, you define this function as it takes a single value, right? And you name it x. And then what you have done with this single value is that you said x to the power of 2. Okay, so you define this function as it only works or operates on a single value. So if I have something like list 1 that contains multiple elements like this, and I tried calling this function, but instead of calling the function and give it a single value, I give it something like list, for example. I give it like this list 1 right here. This does not make any sense. Okay, it may not throw an error, but this is not what you intended when you created this square function. When you created this function, your actual goal was to square a single number, but now you are passing a list to a function. It doesn't really make sense to say that the passed list, okay, the passed list into this square function will be substituted with x. So when you pass a list to this function, within the function, x is going to be implicitly substituted with the passed list. So Python is going to do something like this. It's going to say x equals whatever you passed to the function, and in this case it is equal to list 1, which is in this case these elements, right? So x is going to be these elements, this list, and it doesn't make sense to say x, which is a list, to the power of 2. So in order to make a function accept a list in the function call in this area, you need to program the function, or you need to define the function in a way that actually it operates on lists. Okay, so again, I will say this for the last time because this is really important. When you want to pass a list into the function, you need to make sure that you have defined the function in a way that actually it can operate on a list, on any list. Okay, so now let's return this to be 2 as it was, and I'm going to discuss something really quick with you before actually making an example on a function that accepts a list. Okay, what is the summation of these elements? Now take a moment, it's really simple here. 10 and 20 is 30 plus 30 is, the summation is basically 60, right? But how do you get this? In order to get the summation of every element in a list, do not forget this in any language. When you hear that you want to get, for example, the summation of elements, okay, in a list without actually completing the question itself. When you see that you are getting the summation of elements, okay, you should know that you will be iterating over each element. You need to iterate over the first element, keep it at somewhere, okay, then iterate over the next element, add it to the previous element that you have iterated through, okay, and store the result at another area, iterate over the next element, which is the last element, and add it to the previous two elements. Yeah, so this is what it means when you see something like print or return, make a function that return the summation of elements in a list, or print the elements of a list, or for example give the average of elements in a list. Since you are working on a collection of items or elements, you should know that you're gonna need for loop. Okay, this is a concept that is fixated in every language. When you hear that you are iterating or you want to get to make some operation on multiple elements inside a list or inside an array or inside the tuple, you will need a for loop in order to iterate over each element. What do you do when you iterate over each element? What will happen when I'm actually standing at this element right now, or I'm actually standing at this element or at this element? This is up to you. This is up to the question itself. Okay, so let's make for loop, and when we are iterating over elements in a list, we said that the for loop is going to be for x in the name of the list, which in this case list 1. Before I do anything, let's just print the x, which is going to be each element of this list 1. So if you run this, you're gonna see 10, 20, and 30, right? But we don't really want to print it. And now that's what I was talking about. What do you want to do when you iterate through the elements? See this header here? This is iterating over each element inside this list. Okay, this is the iterator of the for loop, and this is the list that we are iterating through. So this is iterating through the elements. But what is next? Okay, I am iterating through the elements. What is next? What do you want me to do? Do you want me to print each element? Do you want me to add each element to the previous one or the next one? What do you want me to do? Now, the question here was asking you to get the summation. Now, we know when we are getting the summation of any multiple elements, we say that we have something like an initial variable. We call it, by default, we call it sum, and we say that sum is equal to 0, right? Before we start anything. So this is it's always our starting point. Now we are iterating over each element. You say something like sum is equal to sum plus x. So what is happening here? I believe I have explained this multiple times before, and I think this is in the 4th lab as well. I believe so. So what is going on here? So remember that when you are starting the loop, the x is the first element of this list. So the first iteration of this loop, remember that this loop was going to run for 3 iterations because the list that we are iterating through actually have 3 elements. So we have 3 iterations. Okay, the iteration here equals the number of elements when we are iterating through a list, right? Now for x in list 1, in the first iteration, x is going to be the first element in this list. So in the first iteration, x is going to be 10. Yeah, so you enter the loop with this knowledge. You know that x is 10. Alright, so x here is 10. When you see an assignment statement like this, an assignment statement is basically an equal sign. This is the assignment operator, and this is the right hand side, and this is the left hand side. Okay, when you see an assignment statement like this, you actually, what you do first is evaluate the right hand side, then store whatever will be resultant of this right hand side into the variable to the left hand side. Okay, so you start with x equal to the 10, which is the first element in the first iteration, right? And the sum, you started the sum with 0, so you say that 0, remember that I am evaluating the right hand side first, 0 plus x, which is in this case 10, so the resultant of the right hand side is going to be 10, and 10 is going to be stored in the sum of the first iteration. Now when Python goes to the next line, it will see that there are no next lines, so it will go back to the head of the loop and iterate through the next element. And the next element in this list that we are iterating through is 20. So now x is going to be equal to 20. Now it will enter the loop with the knowledge of that x is now 20. Remember, the previous sum was 10, so we are evaluating first the right hand side. Now the sum of the previous iteration was 10, and now x is the second element, which is equal to 20. So the evaluation of the right hand side, which is sum plus x, is going to be 30, and 30 is going to be stored on the variable on the on the left hand side. Yeah. So Python will go to the next line. There is nothing here, but we will not like break out of the loop yet. We will go to the header of the loop and check, is there any element left? Yes, there is the last element in this list, which x is going to be in the last iteration, 30. Remember, the sum of the previous iteration was actually 30 here, and the x now is equal to the last element. So the right hand side will evaluate to 60, and this is what's going to be printed, or this is what's going to be stored in the sum on the left hand side. Okay, Python will go to the next line and it will find that there is nothing here, so it will go to the header of the loop. It will ask the header of the loop, is there still any element to iterate through? It will find that no, there isn't. We have actually iterated through every element, so it will eventually break out of the loop. Okay, so now if we print the sum, you should see the value 60. Okay, now I know that you understand this, and I have actually explained this multiple times inside the lab and stuff like this, but let's talk about the probability that we have something like another list, call it list 2, that contains, for example, 100, 200, and 300, and we have something like list 3 that contains, for example, 80 and 20, and that's enough, for example. Okay, let's say that we want to get the summation of list 1, and we want to get the summation of list 2, and we want to get the summation of list 3. So notice that these 3 lines, these are the most important or the most common lines that you need to use when you are getting the summation of any list. Yeah, so you start a summation of 0, then you loop or you iterate through this list, and then inside the list you say the default line that we are really bored of using, which is sum equals sum plus x. So these are the common 3 lines, right? So I'm just going to copy this, and I will make this 3 lines for that. I will make these 3 lines work for the list 2 or for the second list, but I will just need to change the variable names so it won't override themselves. So I'm just going to use sum2, and the loop should iterate over list 2, and we are working now on sum2, and here is sum2. Yeah, I will do the same thing for the third list, but I will overwrite, or I will name the variables to be new variables like this, and the loop is going to go through list 3. Now we are working on a whole different set of variables, which are sum3, and by the end of the day, when we finish iterating over each list like this, what I will do is print sum1 and print sum2, print sum3. Okay, and you should see the result like this, but you can actually tell that this is not actually a good way to like work your solution of this question. What if you have like 100 lists? What if you have 1,000 lists? Are you going to copy this 3 lines like 1,000 times or 100 times? This doesn't make sense, and this is where the function shines. The power of the function comes exactly in this area. The point of a function is basically, because I have heard this question so many times, and you are completely right to ask this question, which is, if we want to get the square of a number, why did I just go outside of the function and say that I have x equal to whatever, and say that x to the power of 2, here you go, I have the square, and just name this or save this in a variable called result, for example. So I have done everything, but instead of doing this in a function, I have done it easily outside of the function. I mean, this argument is partially correct, but when you look at an example like this, you will find that the function comes really handy in a situation like this. Why? Because if you look closely, you'll see that these three lines are the common lines in every situation that we need to sum elements inside list, right? So we can actually have these three lines in a function to use the function as a template, right? So if we have these three lines, you notice that the only thing that changes is the name of the list. That's the most important thing. I don't care if I named the sum to sum2 or sum3. That's really irrelevant. The most important thing in every three lines of these snippets of codes was the header of the loop. Okay, the header of the loop is what actually decides what should be iterated through and what should be summed. So this is the most essential part. Okay, so instead of having these three lines to be copied and pasted for every list that we face, we can just copy this three lines and paste it inside the function and use this function as a template and give it just a list, and this list by default should get you the sum. Okay, that's what I meant by using the function as a black box, as a template. Okay, so let's define a function and call it sum elements like this. And inside some elements, I'm going to copy the three common lines that I've used for list 1, list 2, list 3. Okay, let's indent this the correct way. Okay, I'm going to have this as sum like this. And by the end of the day, we should print sum or return sum, right? But notice something. Now we are working on any list. We shouldn't only work on list 1 or list 2 or list 3. This is a generic list. Okay, so this can be any list. So instead of having this list as list 3, which is here in this case, I'm going to name this something meaningful to me, which is any list. Any list that the user will provide to this function when we call it. So the user should call this function and give it any list like this. Okay, this is what we are operating on. So whatever the list that the user will pass when he is calling this function, the loop will iterate over it and will get the summation of its elements. Okay, and by the end of the day, if the question is asking you to return the summation, so you're going to say return sum. If the question is asking you to print the summation, so you're gonna print sum. It's really dependent on the question itself. If the question didn't specify anything, then it's up to you whether you want to return or print. But remember that returning is really good. It's really useful, because at some point you would want to reuse the variable that have been returned from this function. So always remember that returning is a better solution. Okay, now see, this template is actually efficient for me, and I don't really need all of these three lines anymore. And instead of these three lines, a single function call to this line will be sufficient. Okay, I don't need this comment anymore. Now, we don't really want to work on square function. I was just illustrating this at the beginning. Now notice this. You have three different lists. Okay, you can now call the function that is called sum elements like this. Call sum elements and give it, for example, what do you want to give this template at the beginning? Give this template something like list 1. Okay, now notice that when Python executes this line, okay, it's going to take the past list that you have given the function, which is list 1 in this case, and it's going to get to the part of the script where you have actually defined something called sum elements, which is in this snippet of code, or this couple of lines from 9 to 13. It's going to take to the definition of the function, and it's going to take the list that you have passed, which is list 1, and substitute the parameter or the generic list that you have actually put inside your template or inside your definition with the given list. So it's going to take list 1, go to the definition, say, okay, you have something like any list as a parameter or a placeholder. Replace or substitute this placeholder with the given list from the user, which is list 1. Okay, and remember that list 1 equal to this couple of elements. Okay, so Python is going to start executing the function when it sees this call, with the knowledge of that any list is now equal to the given or past list, which is in this case list 1, that equals 10, 20, and 30. So it's going to start executing these elements, and it now knows that any list is basically list 1, which is 10, 20, and 30, and it should return the sum as 60. Okay, so remember that there is a return here, so I'm just going to print whatever the function call will return. And if you are giving list 1, so get prepared that you will see 60 be returned like this. Okay, now we can actually call the same function, the same exact function, which is sum elements, but instead of giving it list 1, now we are going to give it list 2. Okay, and just understand this as like you have a template and you are making copies of this template, or Python is implicitly making copies of this template. Okay, whenever you call this function, you create a template with a given argument. So at this line, for example, a template of some elements was created and passed to it the first list, or list 1. At this line, another template implicitly Python has created from some elements with a given list of list 2. Okay, and you can call this function whatever number of times that you wish. It's really fine. That's the beauty of having functions. So let's say that we are going to call this function with list 3. Notice that you have saved yourself so many lines. Instead of copying this 3 lines for every list that you face, you have just cut like 3 lines of code into 1 line of calling. Yeah, okay, so that's the point of functions. Now if you run this, the first line or the first print statement is basically the return of the call of some elements when you pass to it the list 1. Okay, so the summation of these elements are 60. Okay, the second print is basically the summation of the elements, or the call of the function that is called sum elements when you pass to it list 2. Okay, so the result of these summed elements are 600, and the last element, which is 100, is basically the result, or the returned value of the function sum elements when you pass to it list 3, which is going to be 100. Okay, now this was the illustration, which was actually creating a function that gets or returns, notice the returns here, which returns the sum of the elements. Now let's see the programs that we have. Okay, we have only 2 programs in this section, in this video. So we're gonna get to the first program first, which is program 6. Okay, so let's see program 7, which is the last program in this lab. It's telling you that you should enhance program 2. Now let's go to program 2 and just remember what it was asking you to do. In program 2, we did something called an even odd detector. This even odd detector, it was accepting only one number as an argument, which is a single value, not a list or anything. And it did not store this number anywhere. It just takes the number, yeah, and it checks if the number is even or odd. If it was even, then it returns a string called even. If it was odd, then it returns a string called odd. What we are enhancing in this case is basically storing or appending the evens that we meet inside a list, or the odds that we meet inside a list. In this case, for example, you have like 2 evens, which is 10 and 50, and you have like 2 odds, which is 21 and 23. So basically, the evens that we are going to meet when we iterate through these elements inside this list are 10 and 50, and we want to append this 10 and 50 inside some empty list that we will create locally inside the function definition, which for example here is called evens. And when we meet any odds which are in this case 21 and 23, we are also going to append them in an empty list that we are going to create locally inside the function, which we happen to call it as odds in this case. So the function, as it say here, it should take one list as an argument. See this function, we call it even odd in list, and it should take one list as an argument. This list, remember, this list is a generic list that can be named anything that actually indicates that we are going to give a list into the function, so we can call it any list, some list, a list. Remember that this is a generic list that's going to be substituted with an actual argument or an actual list when we call this function after the definition finishes. Okay, so what should happen is you give the function a list, you actually iterate over each element in this list, which is actually this line here. You're saying for each element in this in this generic list, and for each element check, just put an if and else statement inside. See if this element, if it's even, then append it into evens, and if this element was odd, then append it into odds. And by the end of the day, it tells you that this function should what? It should return, and that's really important. The function should return the odds and the evens. It should return both lists by the end of the day. Okay? Now let's do this. Let's just copy this snippet of code and place this function here. We don't really need these comments, and I'm going to take this list as well. Let's call this nums2, for example, because we have nums already. Now let's just let's fix the indentation here. I'm really sorry, I'm having a really bad cold during the previous 3 days, so just don't mind me. So now we are passing any list or some list or whatever. Let's just call this any list because I think we are used to say to name our variables this way. Any list like this. Now let's say that I'm iterating through each element. Okay, now check if each element, if it was odd or even. Let's start with even first. If it was even, then append this element, which is x, which is the even element, which is x in this case, inside evens. Yeah. Else, if the element was odd, which is else in this case, then append this element into odds, and that's it. Now notice that we will return what? We should return the evens and the odds together. But remember something, when you place the return, remember that you place the return out of the for loop, because now you are returning inside the for loop. Okay, so you get out of the for loop like this, now you are inside the function, and this is the correct way to do it. Okay, now let's call or let's just print, let's save whatever is returned. I will tell you why shortly. Let's say that result will equal the call of the even odd lists. Okay, and let's pass to it the nums2, this list here. Now let's print result, and notice that the first list return is the evens, and notice that the next element returned is the odds. And if you notice something, the returned structure is a very big tuple. This tuple contains two lists or two elements. So if you want to get the first element, which is the first list in this tuple, which is basically the evens, because we have ordered the returns like this, evens then odds, you can say something like evens will be result of 0, and you can say that odds will be result of 1. Okay, now if you want to be more implicit, you can say something like this. You can say that the evens for x and result of 0, which basically the evens. So print x. Okay, and you should do the same thing with the odds here. Remember, this is just an extra point I'm doing. You don't have to do this. Okay, and we are iterating over the second element. So this is evens and this is odds. Now, I haven't really talked about this inside the lab, but if you want things to be um, on the same line, you can actually make the print statement within the for loop itself work without getting it to like go a new line to the bottom. You can say something like this. Just add an extra feature here and an extra key called end, and set the end. Remember, the default for print functions is that the end is something like this. It's a new line, a new character, a backslash n, which makes actually the print function goes a new line. So if you specify that the end should be something like an empty space, there's nothing here, empty string, things will be like, it's going to be 10 is going to be concatenated with no spaces to the next element, which is x in this case, in this result 0, which is in the evens, which is 50 in this case. But if you set something like a white space to separate each print with the next one, so this is what you get. Okay, now before you print the odds, just remember to go a new line like this, okay, and do the same trick here and put a white space. I believe, yeah, we have to say end here as well, because we don't want the evens to, like, after this print, we don't want it to go a new line like this. Okay, so these are the I don't know, maybe the enhanced formatting or output formatting that I have never talked about inside the lab. Remember that this is optional. If you are satisfied with this look like here that we have done earlier, that's fine. If you want to make a for loop that I've done earlier, that's fine. If you want to make the for loop work like that, just to make everything printed in one line, this is the way to do it. And this is lab 5. Thank you.